Welcome back to the Turd Ferg Show. Alright, so in the video that we've got here, here's what's going to be on. We're already in a lesson looking at magnetic fields, and the only equation we're using in this video is this one, B equals mu OI over 2 pi R. And mu O, if you have forgotten, is 4 pi times 10 to the negative 7. So it's called the permittivity of free space. And that equation just lets us find magnetic field strength anywhere near a conductor. Now this problem is a very, very, very common question. It's given you two wires. One has 5 amps being conducted this way. The other one has 5 amps being conducted in the opposite direction. And what it's going to do is this. It's going to ask you to find what B is in the middle, what B is over here at this point P1, and what B is over here at this point P2. Now, what makes this different is this. Each of these wires is going to have each wire, in other words, that one and that one, each wire is going to have its own magnetic field present at every one of these locations. Now, in some of the spots, they're going to add together, and in some places, they're going to take away from each other. So all you're going to have to do is you're going to have to go through each one of these and use this formula and find B, and then you're either going to add the two together or you're going to subtract the difference between the two. And that's it. And if you look at these choices, it's saying the direction it wants to know as well as you do it. So let's just go ahead and get some little free space here and start doing this problem. So we've got two wires. So I'm going to draw my two wires on here. And one of these wires has got 5 amps being conducted that way, north if you will. The other one has 5 amps being conducted towards the south in this question. It tells us some interesting stuff. It tells us that the 2 points are 10 centimeters. The two wires are 10 centimeters apart. And then it gives us a second location. I think it called it P1. It doesn't matter. But it called that location, said it was 10 centimeters from one of the wires. And then it said, my scale's going to kind of suck here, but there was another point that was 20 centimeters. And they called that P2. And what we're going to be looking at in each one of these cases, we've already said this is going to be our formula. Mu OI 2 pi R. And one thing I don't like is this problem actually gave us 5 amps for both conductors, 5 amps here, 5 amps. Because normally I kind of write, normally my notation looks like this. B for the 5, and then I work out and solve my problem. The problem this time is they gave us equal amperages, so I can't use this notation. So I may end up calling this left wire and this one right wire. It really doesn't matter. I just need a little form of notation anyway in this problem before we get into it. Now, here's the thing. It gave us these 3 spots. The first spot it said was dead in the center. So what I'm going to do is this. I need to know how far away each of these wires are from this location. That's what I need to find. So I'm going to, at this point in the middle, I'm going to find B. So B for the wire on the left would be mu O times 5 divided by 2 pi, and then the R on it, this one would be 0.05. It'd be half of 10 centimeters, and I do have to have it in meters before I do this calculation. So that would be the equation for the one on the left, and then the one on the right. So what would B be for my right wire? What would be my magnetic field strength? Well, if you actually look, it's the exact same, because in the case of the wire on the right, you've still got a 5 amp current, and you've got a 0.5 radius. Now I'm going to do something. I'm going to write it out just to show you how to simplify this. 4 pi times 10 to the negative 7 times 5 over 2 pi, and you already notice the 4 pi and the 2 pi, and that simplifies this, 0.5. When I go to put this in my calculator, I don't type all this in. My first video I did, but I don't. This 2 pi reduces this to nothing but a 2. So all I'm going to put in my calculator is 2 times 10 to the negative 7 times 5 and divide by that term on the bottom. So 2, 10 to the negative 7 times 5 divided by 0.5. And it would be like 2. 2 times 10 to the negative 5. So this is 2 times 10 to the negative 5 Tesla. And the other one would be the same thing. 2 times 10 to the negative 5 Tesla. You could even write 20 micro Teslas down for each one of these if you wanted to. Now, this is the only thing we got to really kind of pay attention to. We figured out what B is for both wires. We figured out each one's magnetic field strength. But now here's the thing. They're both 20. The only difference in the two wires is one of the wires is conducting south, the other wire is conducting north. So we got to figure out, and this is the whole catch now to the problem. You figure out these B's, and now you got to ask, are they adding or are they subtracting from each other? Well, this is where that right-hand rule comes in. So I want to take a look at the right wire first. So I want you to take your right hand and I want you to wrap your hand around the wire in such a way that your thumb points in the direction of the current. And so I'm going to wrap my fingers around that wire. And when I do that, you're going to notice something. On this side, my fingers are directed into the page. And on this side, my fingers are directed out of the page. And that's important. And now I'm going to do the same thing for the other picture. For this guy over here, I'm going to point my thumb in the direction of the current. And I'm going to wrap my hand around that wire. So I'm going to wrap my hand around the wire, and when I do that, I'm going to notice something. On this side, my fingers are running into the page, and on this side, my fingers are coming out of the page. I'm going to leave this here for every other problem, because this tells me the direction of the field. And what's neat in this case is if you look in this middle ground, if you look in this middle area, both magnetic fields are both directed in the same direction, which means the answer to this one, B for the middle, is going to be 40 microtesla, and it's going to be into the page is what's going to happen. And that's kind of the catch in this. Every problem is going to work like that. We're going to find this B, and then we got to figure out a direction using our right hand as to where it's going to go. Well, let's slip over here now, and I want to do something. Let's take a look at this P1. Let's see if we can find that one. So I'm going to get this out of my way. So we found B for the middle. It's 40 microteslas in the middle. Now let's come back over. Same equation. So how about this point? Give me a different color. This point over here, P1. So let's see if we can't find the strength of the magnetic field. Well, we already know the equation. It's going to be B equals mu O I 5. Now we haven't said which one am I doing yet. 2 pi. Which one am I doing? Let's do the wire on the left. So how far is point P from the left wire? Well, if you look from the wire on the left, I'm a total distance of 20 centimeters. So I'm going to do 0.2 on that guy. B on the right. B on the right. Let's see, the right wire, mu O, 5. Don't know why I keep writing the amps. 2 pi, and it is only 10 centimeters away. So we got two different B's from the left and the right. So now I need to sit here and do some calculations on this. Remember, mu O, permittivity of free space, is 4 pi 10 to the negative 7. So 2 pi into the 4 pi, that just leaves 2 10 to, oops, don't need to hit that, 2 10 to the negative 7 times 5 divided by 0.2. And that gives me, in this case, this one would be 5 microteslas. And let's see what the other guy is. Let's see, he would also be 2 times 10 to the negative 7 times 5, which is same as last time, divided by this time 0.1, and this guy's 10 microteslas. And you should be trying to figure out, how come the field is so much stronger from the right? Well, it should be obvious that you've got an inverse relationship. So since this point is closer to the right wire is going to generate a stronger magnetic field. Now, we need to go back and do something. We got to figure out these directions. You're either going, the answer to this problem, the answer is either going to be 5 or 15. You've got to figure out, are these going to add together or take away from each other? So I'm going to go back and do something. Look at the right wire. Anything to the right of the right wire, anything to the right, look at the dots I've already put here. Anything to the right of that wire is going to be coming out. So my 10 is 10 microteslas out of the page. Anything to the right of that wire is out. Now, go to the left wire. Anything to the right of the left wire, look at where my fingers were over here. Anything to the right of the left wire, now see, that's actually opposite. That's going in. So now, if you're trying to figure out what the answer is, B at point P1 is equal to, in this case, 5 in and 10 out means you're going to have an answer of 5 microteslas out is actually going to be our answer for that spot. This is why you've got to establish and wrap your hand around these wires before you get started at this point. Alright, so far we're doing pretty good. Now I'm going to go back and I'm going to erase what I've done so far. And I'm going to go figure out the one on the left. So point P2. So this is for point P2. So B for my left wire would be again mu OI, which is 5 over 2 pi. And now, how far is the left wire from point P2? And it says 20 centimeters. So that's 0.2. I already know the answer to that. I just did it a second ago. It was, see, when we did the math on that, we came out with 5 microteslas. And then let's see, B for the right wire would be mu O, 5 amps as well for it, 2 pi. And this one is now, if you look, the right wire is a total of 30 centimeters away from point P2. So I'm going to break out my calculator and punch that in real quick. So let's see, what was it? 2? I hope I've been doing math right on that so far. I'm going to check. Yeah, I've been using 2. 2, 10 to the negative 7 times 5 equals that, divided by 0.3 equals. And, ooh, that one's not as cool, but it's 33 microteslas. I'm too lazy to write all those 10 to the negative 6s out, so I like doing that. Now we need to figure something out. Are each of these in or out? So let's do the left wire. Anything to the left of the left wire is coming out of the page. Write that here and circle it since I'm using the same color. Now anything, I'm going to go to the right wire. Anything to the left of the right wire, anything to the left of the right wire is going in to the page. So when we look at this problem, the difference is 28 microtesla. Actually, that's not very good math. Yes, it is. 28 microteslas in to the page. And that is how you work this problem. Anyway, it takes a little while to get into this, but this is a very common problem that you have to work. And you see the equation you're going to use, and now all you got to do is come back and apply these directions. And you're either going to put them together or you're going to subtract them based on the right-hand rule. Anyway, thank you.